Hey, what's up everyone? Alex here with GMAT Ninja. Welcome to our Quant video, Number Properties Part 2. So the goal of this video is to build on the fundamentals that we covered in Number Properties Part 1, but to weave those fundamentals into more complicated scenarios. So we'll add things like word problems, sums, sequences, factorials, and the difficulty of these questions is going to be bumped up from that first video. All these 6 questions you're going to see are all solidly in the 80+ range, and they're going to add some extra challenges. So I wouldn't worry if you get stumped by some of them. The goal is, can I get used to dealing with potentially intimidating setups and learn to spot the number properties fundamentals hiding beneath the complications? So as we said in the last video, number properties shows up fairly regularly on the quant section. So this video is going to consist exclusively of multiple choice, problem solving questions like you'd see on the quant section, 6 questions total. And the way it works is we'll put the questions on the screen for 2 minutes, give you a chance to solve it, and then I'll step in after that with the solution. All right, great. Let's take a look at the first question.
Hey everybody, Charles here. Sorry for the interruption. Before we get you back to that quant content, 3 quick things I'd love for you to be aware of. First of all, this video is part of our full, free, complete GMAT course that's available up on our YouTube channel. If this course is saving you money that you would otherwise spend on a course or a tutor, please consider donating some of that savings to charity, either a charity that you love. If you don't have a charity that you love, we've got a list of charities that we love to support on our website, gmatninja.com. Second thing, if you love that presenter that you're watching in this video, not me, the other one, they offer one-on-one tutoring. If you're interested in that, gmatninja.com and we can set you up. Third thing, finally, if you're doing great on the GMAT, doing great on the GRE, starting to look for admissions help with your applications for grad school, we would love to refer you to a bunch of our favorite companies. So just hit us up. There is a contact form on our website, gmatninja.com. Also, a link in the video description. Just fill that out. We'll send you a list of our favorite admissions consultants, not just at our company, no strings attached, not going to sell your email, not going to try to sell you anything. We just want to make sure if you've put in the hard work on the GMAT, that you end up in the best possible hands if you need help with your applications. All right, that's it. Enjoy the quant.
All right, let's take a look at this question. On the northbound lane of Highway X, colored road signs are placed at 1-mile intervals. Every red sign is followed by a blue sign, every blue sign by a green sign, every green sign by a yellow sign, and every yellow sign by a red sign. Paolo began his car journey halfway between a red sign and a blue sign on Highway X after driving north for 2,517.75 miles. What color sign is Paolo closest to? Okay, so as we said in the intro, a lot of these questions are going to have an intimidation factor, but at the end of the day, they're going to be dealing with the exact same fundamental number properties concepts that we talked about in the first video. So I can sense some layers here, some disguises, but hopefully once I peel those away, I'm going to find a fairly simple number properties concept at the heart of the question. So let's see if that's the case here. Okay, I notice I have this repeating pattern of colored road signs, okay? So I'll write out a few iterations of this pattern, see what I can learn from it. Okay, I can't help but notice there's 4 elements in this pattern, so hopefully that'll be helpful. Now I'm being asked, well, what color am I going to be closest to for a really high number once I've traveled a really large distance? So obviously I can't write out all the way to 2,500, etc. But hopefully I can find a pattern that'll help me figure out, well, what color am I going to be closest to? So if I number these elements of the pattern, I can't help but notice, well, multiples of 4, every multiple of 4 corresponds to the same color. In this case, if I call red number 1, then every multiple of 4 is yellow. Okay, great. So now, presumably I can leverage this to figure out what color am I going to be at for a really big number. So let's just say I wanted to figure out for number 51 in this pattern, what color is that going to be? Well, I know every multiple of 4 is yellow. So the question is, 51 is how far past a multiple of 4? Okay, so if that sounds familiar, that's good. We're dealing with remainders here. So what's the remainder when 51 is divided by 4? Well, 4 times 12 is 48. 48 is 3 away from 51, so I have a remainder of 3. So that tells me 51 is 3 past a multiple of 4, or 3 past yellow in our pattern. So 51, we're going to go 1, 2, 3 past yellow. So 51 would land us at green. Okay, great. So I've got a handle on sort of the central aspect of this question, but I can't help but notice my numbering scheme here isn't super intuitive in terms of distance traveled. And here's what I mean. If my starting point is red, let's say, and I travel a distance of 2 miles, I end up at number 3 with this numbering scheme. So calling my starting point 1 doesn't make a whole lot of sense. I'd like these numbers to maybe correspond to the actual distance traveled. So if I think about it, it makes a lot more sense to number my starting point 0, and then once I've traveled 1 mile, I'm at blue, and so on. Okay, so this seems to rectify that problem. If I've traveled 2 miles, 1, 2 past my starting point, I'm at 2 in my numbering scheme. Great. Now I notice my multiples of 4 have shifted. Now multiples of 4 are red, but that's okay. Still the same basic concept. 4 is red, 8 is red, 12 is red, etc. Okay, so now speaking of starting points, I mean, I've been kind of assuming a starting point of red for this demonstration, but if I read closely, aha, I'm starting halfway between a red sign and a blue sign. Okay, so my 0 point is actually not at red, but halfway between red and blue. That's okay. I'll just shift all of these numbers forward by a half. So if 0 is halfway between red and blue, then 1 would be halfway between blue and green, and 2 would be halfway between green and yellow, and so forth. Okay, and now I'm most interested in my multiples of 4, and I notice, okay, my multiples of 4 are all going to be halfway between red and blue. Okay, so now how many miles am I traveling here? Well, I'm going 2,517.75 miles. So the question is, okay, what's the remainder when that's divided by 4? All right, so I could do the long division there, but that could give me a headache and I might make a careless mistake. So maybe I could deal with this using logic somehow. So I know 4 goes into 1,000, so it should go into 2,000 evenly. 4 goes into 100, should go into 500 evenly. So really the question is, what's the remainder when 17.75 is divided by 4? That's a lot easier. That's going to be 1.75, right? Because 4 goes into 16, another 1.75 to get to 17.75. Okay, so the remainder of 4, that tells me, the remainder of 1.75, I should have said, that tells me I'm going 1.75 past a multiple of 4. In other words, 1.75 past halfway between red and blue. Okay, so I'm going to start halfway between red and blue, because that's where 2,516 miles would land me in this pattern, halfway between red and blue, and then I've got a remaining distance to travel of 1.75 miles. Okay, so 1 mile starting here would land me halfway between blue and green, right? Halfway between red and blue, I travel 1 mile, then I'm halfway between blue and green. I've got 0.75 to go, so if I go now half a mile, I end up at green. I've got 0.25 of a mile left. Okay, so I'm 0.25 of a mile past green. So there's a distance of a mile between green and yellow, so I'm closer to green. Between green and yellow, but closer to green. So the answer choice here has got to be C. Okay, great. So what do you want to take from that question? Well, again, this idea of an intimidation factor, there's a lot of words on the page here. There's some big numbers. But at the end of the day, when I write out the pattern, I see like, okay, This is a remainders question. If I follow my logic, hold steady with the arithmetic, I should be in good shape. And again, that leads us to the correct answer of C. All right, great. Let's take a look at the next question. All right, let's take a look at this question. X is a two-digit positive integer that has a remainder of 4 when divided by 9 and a remainder of 1 when divided by 6. What is the sum of all possible values of X? Okay, so the first question I'm asking myself here is, should I use the quote-unquote smart method where I use formulas and algebra, that sort of thing, or should I use the quote-unquote stupid method, which sometimes actually is a smarter way to do it, where I'm writing things out, looking for patterns? Well, I'm not really sure. Maybe I'll give the smart method a try, see if it yields anything. Okay, so what do I know about X, two-digit positive integer? Okay, it has a remainder of 4 when divided by 9. So I guess that means it's 4 greater than a multiple of 9. So I could represent that with an expression. I could say 9n, there's multiples of 9, where n is an integer. And it's 4 greater than any multiple of 9, so 9n plus 4. Okay, great. I suppose I could do the same thing with the second piece of information. It's 1 greater than multiples of 6, so these are numbers that when I divide them by 6 would give a remainder of 1. Okay, but let me remind myself this is true. M is an integer is what I'm assuming. Okay, so I think I've represented the conditions that are necessary to satisfy X, also that it's a two-digit positive integer, but algebraically I'm not sure where to go from here. I mean, I suppose I could set these equal to each other, but then I'm going to have two variables, so kind of hitting a brick wall when it comes to algebra. So maybe let's give this stupid method a try. Write things out, look for patterns. Okay, so if X is a two-digit positive integer, maybe there's not that many things to write out. If I want to write out all the possible values of X, I'll start writing them out, see if I can find any patterns. Okay, so what are possible values of X that would satisfy just this first one? Well, I guess if n is equal to 0, then 9 times 0 plus 4 would yield 4. Oh, but that's not a two-digit positive integer, so that's out. Okay, so if n equals 1, I get 9 plus 4, 13. If n equals 2, I get 18 plus 4, 22. Okay, now speaking of patterns, I'm noticing these are both separated by 9. That makes sense. I have a starting point of 4, and I just keep adding multiples of 9 to it. So I'll save myself a little work and just keep adding 9s. 22 plus 9 is 31, then 40, then 49, then 58. How high should I go? Well, I'm not really sure. Maybe I'll see if a pattern emerges before I, write out too many things. So 6m plus 1, okay, I'll do the exact same thing. If m is 0, this would be 1, but that's not a two-digit positive integer. If m is 1, then it's 7, but that's also no good. Okay, and you know what? The same thing, right? My starting point is 1, and then I'm adding multiples of 6, so these are all going to be separated by 6. Okay, great. I'll just keep adding 6, and what do you know? There's an overlap. There's a possible value of x. Okay, satisfies both of these. All right, let me keep going, so keep adding 6. 19, 25, 31. Oh, there's another. Now, I'm noticing, okay, there's a gap of 18 between these two, so now that kind of makes sense, right? Because, well, they overlap at 13, and then I keep adding multiples of 9, multiples of 6. Well, 9 and 6 have a least common multiple of 18. So it makes sense that they would line up again 18 later. So maybe there's my pattern, but I'll just keep writing things out to make sure I reasoned that out correctly. And yep, there we go. Another overlap at 49. That's 18 past 31. Okay, so I can just keep adding 18 to get all the overlaps. So 49 plus 18, well, let's see, 59, 67. Okay, 67 plus 18, so that would be 77, 85, okay. Then 85 plus 18, that's 95, 103. Okay, but that's getting too high. Okay, great. So that was certainly somewhat tedious, but didn't actually take all that long, especially because once I noticed the patterns, it limits the amount of work I'm actually going to have to do to find what I want, all the possible values of x. So what's the sum of all those possible values? Well, I guess I just need to power through this. Now, maybe there's a way of adding these up that's kind of less painful than some other ways. So let's see, is there any way I want to combine these that's not terrible? Well, 13 and 67, those add up to 80, great. 31 and 49, again, those add up to 80, great. Okay, so 80 plus 80 is 160. Add 85 on top of that, I get 245. Very nice, that's answer choice B. Okay, great. So what do you want to take away from this question? Well, was this the smart method, the stupid method? Maybe a little bit of both, right? I mean, these formulas kind of helped me get a handle on, well, what are the sort of possible values of x? But then a little bit of stupid method, I'm just writing things out, but being very alert to when the patterns show up. Sure, this is really tedious, but doesn't actually take all that much time. And then lastly, when I get these numbers, I'm really careful to add them up, not make a careless mistake, maybe find an easier way to add them up. Doing all that leads me to the correct answer of B. All right, great. Let's take a look at the next question. All right, let's take a look at this one. Consider positive integers p and q such that p is greater than q is greater than 3. When p factorial minus q factorial is divided by a positive integer x, the remainder must be 0 when x is equal to which of the following? And I'm given some possible expressions to represent x. Okay, so let's break this down. I've got p factorial minus q factorial divided by a positive integer x. Okay, so what would it mean for the remainder to be 0 here? Well, basically it would mean that p factorial minus q factorial is divisible by x, or that x is a factor of p factorial minus q factorial. So I've got this language about remainders, but it's all boiling down to this familiar number properties concept of divisibility. Is x a factor of this expression? Okay, so let's see if we can break this expression down, make it a little simpler. Suppose I could rewrite it this way. And now I don't need to worry about this whole expression, p factorial minus q factorial. I can just consider p factorial and q factorial separately and see, is x a factor of both of those? Okay, now let's think about the idea of factorial for a sec. So just as a review, 5 factorial would be 5 times all the integers less than 5 going all the way down to 1. And what would it mean for x to be a factor of 5 factorial? Well, I suppose if x were equal to an integer less than 5, it would definitely be a factor of 5 factorial. On the other end, if x were equal to 5 factorial, then it would be a factor of 5 factorial. That's the biggest factor of 5 factorial. Or if it were equal to some product of some subset of these factors, it would also be a factor of 5 factorial. So a bunch of different options there. So let's keep that in mind when we're analyzing p factorial, q factorial. Now, how could I represent p factorial? Well, p is an unknown, but it would still be equal to the product of all the integers less than p all the way down to 1. So I could represent that this way. P times p minus 1 times p minus 2. Those are the integers less than p going all the way down to 1. I could do the same thing with q, going all the way down to 1. Okay, so now I want to figure out, well, does x have to be a factor of that when it's equal to p minus q? So let me consider these separately. And I suppose if it has to be a factor of p factorial and a factor of q factorial, then yes, it would give a remainder of 0 when divided into p factorial minus q factorial. But if it fails on either end, if it's not a factor of p factorial or if it's not a factor of q factorial, then I can eliminate it. Okay, so p minus q, well, let me remind myself what I know about p and q. They're both bigger than 3. P is bigger than q. Okay, so would p minus q go into this expression p factorial? Well, p minus q is going to be a positive integer because p is bigger than q. It's going to be an integer less than p. And we said that p factorial includes all the integers less than p going down to 1. So p minus q is going to be one of those. So yes, p minus q is a factor of p factorial, so that first term checks out. Now, what about the second term, q factorial? Does p minus q go into that? Well, at the first glance, I'm not really sure, so let me just remind myself one aspect of this question. I want to find when the remainder must be 0. In other words, p minus q must be a factor of this expression. So in other words, if I can find one instance where it's not a factor of that expression, then I can eliminate the answer choice, because I couldn't say it must be. Okay, so I'm going to reframe my goal here as I'm looking for an instance where p minus q is not a factor of q factorial. And I might remind myself here, well, if x gets big enough, in fact, if x is bigger than 5 factorial, it's not going to be a factor of 5 factorial. So I could think of that challenge this way. Can I make p minus q really big? Can I make it bigger than q factorial? And then it would no longer be a factor. Now I'm noticing that I can make p as big as I want, right? Q can be small, q can be like 4, but p can be the biggest number I possibly want. So at a certain point, yeah, p minus q is going to be bigger than q factorial for sure. I can make p minus q just arbitrarily big as I want. So just to prove that with an example, I could say, right, well, q could be some small number like 4, p could be some big number like 100, so p minus q 96 is not going to be a factor of 4 factorial, as I suspected. 4 factorial is 24, 96 not a factor of 24. Okay, so that proves that this does not have to be a factor of q factorial, so it's not a factor of p factorial minus q factorial, at least not necessarily. Statement 1 is gone, along with that a and d. Okay, cool, 2 for the price of 1, I'll take it. So now let's look at the next statement, p minus 1. Okay, so same process, but instead of p minus q, I've got p minus 1. Is p minus 1 a factor of p factorial? Well, you bet, I've got it up there. It's an integer less than p, it's going to have to go into p factorial. Is p minus 1 a factor of q factorial? Well, same logic as last time, right? P, I can just make it arbitrarily big. If I make p really, really big, p minus 1 is going to be too big to go into q factorial. So just to revise this expression here, p minus 1 would be 99. That's even worse, right? 99 definitely doesn't go into 24. So statement 2 is out, and along with it, B and E. And look at that, it's gotta be C3 only. Okay, cool. So just for fun, let's go through statement 3, but we should be pretty confident that we can pick C at that point. Now, Q minus 1, does that have to be a factor of both of these? And if our work is correct, then the answer will be yes, but let's see if we can confirm that. Well, Q is an integer less than P, so Q minus 1 would also have to be an integer less than P, and P factorial includes all the integers less than P, so yep, that checks out. And Q minus 1, well, I even have it right there. Yes, Q minus 1 is an element of Q factorial, so Q minus 1 is a factor of Q factorial. So that proves that Q minus 1 is a factor of both of these, and yes, we would get a remainder of 0. Okay, so what do you want to take from that question? So one thought is, yes, that's a really challenging question. There's a lot of moving parts there. So if you found that really challenging, I definitely wouldn't panic. The reason we included it is to give people challenges and to kind of demonstrate, well, you can have a lot of complexities on the surface, but at the end of the day, you're dealing with fairly familiar number properties concepts. Here it's divisibility. We've layered some factorials on top of that, but once you work through the algebra there, things kind of work out nicely and you end up with the correct answer here of C. All right, great. Let's take a look at the next question. All right, let's take a look at this one. If s and t are positive integers and s to the fourth equals 120t, which of the following must be integers? And I've got a bunch of expressions with t divided by some prime factors. So I'm back to the idea of divisibility here, right? If t is divisible by this series of prime factors, well, then it's going to be an integer. So I'm asking myself, does t have all of these prime factors in it? If so, this expression would have to be an integer and so on for all the rest of them. So now the question is, all right, what do I know about t? Well, I'm given this expression, s to the fourth equals 120t. Okay, so what can I do with that? Well, I'm not seeing much algebra I can do because, I don't know the value of s, so I can't really solve for t. So what can I do? Well, I notice prime factors seem to be important. Maybe I'll prime factorize 120. This is equal to 2 cubed times 3 times 5. That would give 120. But I'm still hitting this brick wall. I can't solve for t. I'm not sure what I should do. So let me go back to the question. Did I miss any important information? Well, they tell me that s and t are positive integers. Okay, so that limits the values they can take on. It also says which of the following must be integers. Okay, so I guess maybe t could take on multiple different values, but I'm asking myself, under the worst case scenario, is this still going to be an integer? And if it still does, well, then I guess that expression must be an integer. So what's the worst case scenario for t? You know, if it can take on different values, I guess the smallest possible value of t that has the least number of factors in it. That's the worst case scenario. And if even that's an integer, I guess it must be an integer, the expression. Okay, so those are my constraints. S and t are integers. I'm looking for the smallest possible value of s to the fourth, which would give the smallest possible value of t. And this expression here has to be equal to an integer raised to the fourth power. Okay, so now I notice 2 cubed times 3 times 5 is not an integer raised to the fourth power. So t is going to have some value so that when I multiply it by this, I'm going to get an integer raised to the fourth power. Okay, so what do I know about s to the fourth? Well, it has to have a 2, a 3, and a 5 in it based on that expression. So now I'm asking myself, okay, what's the smallest possible integer raised to the fourth power that has a 2, a 3, and a 5 in it? Well, none of those are, I can't take the fourth root of any of those. So if I have all those factors in it, and it's going to be an integer raised to the fourth power, I'm just going to have to raise all those to the fourth power. 2 times 3 times 5 to the fourth, that's the smallest possible value of s. Now, I suppose I could make bigger values of an integer raised to the fourth power that have more factors, but I want to make the smallest possible one, and I've got to have a 2, a 3, and a 5 in it, so that's going to do the trick. Okay, great. So maybe I'll simplify that expression. I could rewrite this as 2 to the fourth times 3 to the fourth times 5 to the fourth. Okay, great. Now I can proceed. I know my smallest possible value of s in a simplified form. So the question is, what value of t will give that? Because that'll give me the smallest possible value of t. Well, what does t need to be so that if I multiply it by 2 to the third, I get a 2 to the fourth? So t needs to have a 2 in it. Okay? It needs to also multiply by 3 to give 3 to the fourth. Well, I guess 3 to the third times 3 to the 1 would give 3 to the fourth. So t has to have a 3 to the third. By the same logic, it has to have a 5 to the third. Great, I've got my smallest possible value of t, and now I can take it through these answer choices, see which ones give me integers. I should be in good shape. Okay, but before I do that, let me just take a step back and say, if this logic here made sense, where I said, well, the smallest possible value of s to the fourth has to be this expression here, great, you're in good shape. Okay, but if that seems a little hazy, there's also a more formal way you could think about this if you consider a certain number properties rule. So maybe I'll go through that rule, give some examples, and then we can get back to the question. So the rule I'm thinking of says, any integer raised to, let's say, the fourth power, you must be able to write it as a series of factors of that integer, each of them individually raised to a power that's a multiple of 4. Okay, now I chose an integer raised to the fourth power. I could also have said the same rule with an integer raised to the fifth power. I have to be able to write that as a series of factors of that integer, each of them individually raised to powers that are multiples of 5. Okay, but I'll stick with fourth just for our example here. Now that rule was a mouthful, so let me write it out here and we'll do some examples to see, well, why does it kind of make sense? Okay, so some integer I raised to the fourth power, I must be able to write it as a series of factors of that integer I, each of them individually raised to a power that's a multiple of 4. Okay, now let's consider a concrete example to see, like, well, why does that make sense? Does it make sense that I could write 15 to the fourth power as a bunch of factors of 15, each of them individually raised to the fourth power? Yeah, that makes total sense, right? I could write 15 as 5 times 3, all raised to the fourth power. That's just 5 to the fourth power times 3 to the fourth power. Okay, so maybe I'll just consider some slightly bigger examples to keep exploring this idea. So what about 36 raised to the fourth power? Okay, well, sure, I could write that as 9 times 4, all raised to the fourth power, or each individually raised to the fourth power. But if I keep breaking it down, notice I'll get 3 squared to the fourth power, that's 3 to the 8th. 4 is 2 squared to the fourth power, that's 2 to the 8th. Okay, so, yep. Factors of 36, 3 and 2, each of them individually raised to a power 8, that's a multiple of 4. Okay, and one last bigger number, and then we can go back to our question. Let's imagine 180 raised to the fourth power. Okay, so how would I write that? Well, I could break 180 down into 20 times 9, all raised to the fourth power. 20 I could write as 2 squared times 5. 9 I could write as 3 squared. Okay, so if I simplify that down here, what do I get? This is all raised to the fourth power. So 2 to the 8th times 5 to the fourth times 3 to the 8th. Okay, so notice they're not all raised to the same power of 4, but I have my rule demonstrated here. Factors of 180, 2, 5, and 3, each of them individually raised to a power that's a multiple of 4 gives 180 to the 4th power. Okay, so if you think about those concrete examples, hopefully what I'm saying here makes some sense, right? S to the 4th is an integer raised to the 4th power. It's got to have at least a 2, a 3, and a 5 in it, so those are all going to have to be raised to some power that's a multiple of 4. And I'm looking for the smallest possible value of s and t, so I'll say each of them is raised to the 4th power, right? I mean, I could have raised them to the 8th power, 12th power, any multiple of 4, but the smallest possible value would be 4. Okay, great. So s to the 4th has to be equal to this. Again, I walk through my logic. I get t is 2 times 3 squared times 3 cubed times 5 cubed. Okay, so if I look at statement 1 and I divide this by 2 squared times 3 squared times 5 squared, does that give an integer? Well, 3 cubed over 3 squared, 5 cubed over 5 squared, that's fine. I get 3 times 5 on top, but notice I get a 2 in the bottom. 3 times 5 over 2 is not an integer. Okay, so this does not have to be an integer. A is out, C is out, E is out. Okay, is it 2 only or 2 and 3? Well, does t, here's my value of t, does it have to be divisible by 2 times 3 times 5? Yeah, looks like that's going to check out, right? Because I have 2, 3 cubed, 5 cubed, 2 times 3 times 5. It can accommodate that. I'm going to end up with an integer. So this yields an integer. And I'll go on to statement 3. 2 times 3 times 5 times 15. 15 is 5 times 3. So I've got another 5 and another 3. So this becomes 3 squared, 5 squared. And again, yes, this is divisible. The 2's cancel. 3 cubed over 3 squared, 5 cubed over 5 squared. That's going to yield 15. So yes, that's also an integer. So that leads me to my correct answer here of D. Okay, so what do you want to take from that question? Well, again, divisibility, that concept shows up in so many of these questions in different guises, but same underlying principle. And then also this idea about integers raised to powers and what you can conclude from that. And again, this rule here, any integer raised to some power, say the 4th power, I must be able to write it as a bunch of factors of that integer, each of them individually raised to a power that's a multiple of 4. Apply that rule here. And again, that leads me to the correct answer of D. All right, great. Let's take a look at the next question. All right, let's take a look at this question. For each positive integer j, let cj equal 3j squared minus 1. For instance, c1 equals 3 times 1 squared minus 1 equals 2. c2 equals 3 times 2 squared minus 1 equals 11. For which of the following values of n does the sum c1 plus c2 plus c3 plus dot 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 all the way to cn yield an even number? And then I'm given a bunch of different possible values of n that I can evaluate. Okay, so I'm quickly noticing even odd logic seems to be an important element of this question, but there's also this sequences element layered on top of it. Now, one thing to say about sequences is that they often have this intimidation factor. Sometimes people look at them and think, am I missing some fancy sequences formula that I need to solve this question? And a lot of times, actually, sequences questions really benefit from the quote-unquote stupid method. Not doing anything fancy, just writing out a whole bunch of terms of the sequence and looking for a pattern. So let's see if that approach helps here. And just as a side note, I think I like that method because I can't actually write out the first 24 terms of the sequence and add them up in a reasonable amount of time. First 50, 61, that's not going to work. So again, let me write out a bunch of terms and see does a pattern emerge that I can use. Okay, so let's get down these terms. Maybe I'll go up to the 5th term and I'll remind myself the first term they tell me is 2, the second term is 11, the third term, okay, I got to calculate it, plug in 3 for j. 3 times 3 squared is 3 times 9, 27, minus 1 is 26. Okay, the 4th term, well, I'll use their formula, plug in 4 for j. 3 times 4 squared is 3 times 16, so 48 minus 1 is 47. Okay, and the 5th term, okay, I suppose I could keep going, but I'm getting a little tired of this, and let me see if a pattern has emerged yet. Okay, so now the numbers themselves I'm less interested in than whether they're even or odd, because this question is all about, is this sum going to be even or odd? So I notice first term even, second term odd, and so on. Okay, and if I wanted to, I could write out a couple more to confirm this pattern, but it looks like this is going to be the case. The terms are alternating between even and odd. Good to get that down. Now the question is there a pattern that emerges with the sum of these terms? Okay, because I want to figure out, well, is the sum of the first 24 terms going to be even or odd? So let's do another column here where I keep track of the sums of these terms, and we'll see as I sum up more and more, do I get even or odd? Okay, so what's the sum of just the first term? Well, the first term is even, so the sum of the first term, so to speak, is just an even number. What about even plus odd? Okay, let me remind myself of my even odd logic. So an even plus an odd has to yield an odd, even plus even, odd plus odd equals even. Okay, so you could prove those rules to yourself if you want with some examples, but I'm going to rely on those. I'll say the sum of the first 2 terms is an even plus an odd, that's an odd. Okay, what about the sum of the first 3 terms? Well, the sum of the first 2 terms was an odd. Add an even on top of that, even plus odd is odd. What about the sum of the first 4 terms? Well, the sum of the first 3 terms was odd. I'll add the 4th term on top of that. An odd plus an odd gives an even. Okay, so let's just keep going. Even plus even, odd plus odd. Pardon me, odd plus even plus odd, odd plus odd, even. Okay, so maybe that's enough sums here that I've written down to find a pattern, and I notice, yes, these sums seem to have a repeating pattern of 4. In other words, every 4th term in the sequence, or every multiple of 4 is an even, right? The 4th term is an even. The 8th term is going to be an even. Presumably the 12th, the 16th, and so on are all going to be evens. Okay, great. So this gives me exactly what I want to know, because they're asking me, well, the sum of the first 24 terms, is that going to be even or odd? And I know that every multiple of 4, every, sum of the, if I'm adding up a number of terms that's a multiple of 4, I'm going to get an even number. I'm going to be the last one in the pattern. Okay, so if I sum up the first 24 terms, well, that's going to, 24 is a multiple of 4. It's going to land me at the end of the pattern. So yes, that's going to be even. The sum of the first 24 terms is going to yield an even. What about the sum of the first 50 terms? Well, where is 50 terms going to land me in the pattern? Well, what's the closest multiple of 4 to 50? I guess that would be 48. So the sum of the first 48 terms would land me at the end of the pattern. It would be even. So I'll just say there's the sum of the first 48 terms would land me there in the pattern. First 49 terms, back to the start. First 50 terms, okay, that would land me here at an odd number. So the sum of the first 50 terms, nope, that's going to give an odd number. Okay, and maybe along the way I should have been kind of eliminating answer choices based on these, so let me do that. Okay, Sum of the first 24 terms has to be even, so the answer choice has to include 1, so D and E are gone. But the sum of the first 50 terms is going to be odd, so I can't have an answer choice that has 2 in it, so C is gone. Okay, let me evaluate the sum of the first 61 terms. Well, what's a multiple of 4 that's close to 61? That would be 60. So the sum of the first 60 terms would land me here in the pattern. Okay, 61 would take me back to the beginning, but I'd still be even. Okay, so the sum of the first 61 terms yields an even sum, so the answer to this one is B, 1 and 3. Okay, so what do you want to take away from that question? Well, again, even odd logic, that's a common number properties element to know. It shows up in a lot of these questions. But sequences gets layered on top of that. What do you want to know about those? Well, they often feel intimidating, and sometimes they suggest to people, oh, you know, there's a formula that I'm missing, but a lot of times the quote-unquote stupid method works great. Start writing out elements of the sequence and see if a pattern emerges. Once we do that, we're in good shape. We realize that 1 and 3 will both yield even numbers, and again, that leads us to the correct answer of B. Okay, great. Let's take a look at the next question.
All right, 2 last things. Thank you so much for making it to the end of the video. If you've made it this far, you're one of those awesome people that's obviously really engaged in this GMAT thing. We would love your comments and your feedback. If there's anything else you'd love to see in our videos, hit us up in the comments. We'll do our best to oblige. Second thing, if you're enjoying it, hit that like button, hit the subscribe button. Helps other test takers like you find our full free video course. You need anything else? You know where to find us, gmatninja.com. Thanks so much. Enjoy this last question.
All right, let's take a look at this question. Town Z plans to install B identical benches on a straight path that runs through a park from east to west. The distance between the first bench and the eastern end of the path must be equal to X yards, and the same is true of the last bench and the western end of the path. Additionally, any 2 adjacent benches must be separated by a distance equal to X yards. The total length of the path is 296 yards, and the length in yards of each bench is an integer. If X is equal to 1/3 the length of each bench, how many benches can the path accommodate? Okay, so I've got this deluge of language and information, and the challenge at this point is, can I get this down in terms of math language? Can I get equations and variables and define my numbers, maybe a diagram, and then hopefully that'll lead me towards a solution for B, the number of benches. Okay, so where should I start? Well, I'm noticing 296 yards is the length of the path. That shouldn't be too hard to represent. I'll draw this path and I'll remind myself, okay, the length of this path is 296 yards. Okay, now what am I looking for? It's always good to keep my endpoint in mind. Well, there are B benches, B identical benches, and I'm trying to find B. Okay, now they introduced this variable x. What did x represent? Well, they said the distance between the first bench and the eastern end of the path was x, so I'll get x in my diagram. I guess that line will represent a bench, and the same is true of the last bench and the western end of the park, so I'll draw another bench on the western end and say the distance there is x. Okay, now they also say any two adjacent benches must be separated by a distance equal to x yards. Now the problem is I don't know how many benches there are. That's actually what I'm solving for. So I can't draw an accurate diagram here. So let me just arbitrarily say, what if there were 3 benches? And maybe that'll give me a sense of, how x and the length of the benches and the length of the path relate. This isn't necessarily the correct number of benches. I don't know how many benches there are, but this is just to kind of demonstrate the situation. I'll draw it this way. Okay, great. So I've got a lot of the information down. Anything that I'm missing? Well, they say the length of each bench in yards is an integer. Okay, well the length of the benches, I haven't defined those. They didn't give me a variable, so I'll just make up a variable for that. I'll say y is the length of the bench. Y is the length of these benches. And importantly, presumably, y is an integer. Okay, I'm not sure how that plays in yet, but maybe it'll become important later on. And they also tell me that the length of each bench is 1/3, or rather x is equal to 1/3 the length of the bench. So I could say x is equal to 1/3 y, y being the length of the bench. Okay, so I think I've got all this information down. The question is, how can I relate it all, hopefully to create an equation that I can then solve for b? All right, well, if I add up, all these benches and spaces, it should add up to 296. So let's see if I can do that. I want to add things up to equal to 296. And if I account for all these benches, well, there are b benches, and they each have a length of y, so that's a total distance of by. But then I have to add the spaces. So how many spaces are there? Well, in my diagram, I have 3 benches, and I notice that there's 4 spaces. There's 4 x's there. And does that make sense? Well, I guess I can justify that, right? Because there's a space before each bench. So if I got 3 benches, there's 3 spaces, and then 1 more space at the very end. So it looks like however many benches I have, there's going to be 1 more space than that. So 3 benches, 4 spaces. If I have b benches, I guess that's b plus 1 spaces. So I've got these b plus 1 spaces, each with a length of x. Okay, so I achieved my preliminary goal. I translated all my information, and I now have an equation that includes b. So let's see, what can I do to work my way towards a value of b? Well, I've got 3 variables. I'd like to reduce the number of variables if I can. Anything here I can use. Well, x is equal to 1/3 y, so I can substitute in for x. Great, I'm eliminating a variable. What's my next line of algebra? B plus 1 times 1/3 y instead of x there. Okay, anything I can do at this point? I suppose I could distribute. Why not? So I'm going to distribute the 1/3 y, 1/3 by plus 1/3 y. And notice at this point, I'm in a little bit of just pushing the algebra ahead, not really sure where it's going to go, but hopefully things will get simpler and I'll be able to find a value for b. So I'll just keep pushing. Anything I can do at this point? Well, okay, I've got these like terms. By plus 1/3 by is 4/3 by. Okay, hopefully that makes things simpler. Anything I can do at that point? I've got these fractions. I'm not a huge fan of fractions. Maybe if I multiply those, that'll make this simpler. So I'll multiply this whole thing by 3. What does that give me? 4by plus y equals 296 times 3. I'm feeling kind of lazy. I don't want to multiply that out. So if I absolutely have to, I can do it later, but I'll just leave it as 296 times 3 for now. And what can I do at that point? Well, there's only one last thing that's occurring to me in my algebra toolkit is I could factor out a y. So I'll do that. And what am I left with? Y times 4b plus 1 equals 296 times 3. Okay, so why did I do all that algebra? I was just hoping things would get simpler and that maybe I could solve for b. And I think I achieved making it simpler. That's a lot simpler than what I started with. I've got fewer variables. It looks a lot neater. On the other hand, I'm still not able to solve for b because I don't know the value of y. So algebraically, I'm kind of stuck. So is there any information here? I'm going to scan the question again, scan my information to see if I'm not taking account of anything important. Aha, y is an integer. Let me not forget that. Okay, when they mention that, it's often going to play a role at some point in the question. So if y is an integer, and let me think about it, b, actually the number of benches, also has to be an integer, that means that these two, everything on the left-hand side is going to have to be an integer. And when I multiply those, I'm going to have to get 296 times 3. So there's really only a limited number of values that these could take on, so that I'm going to get a product of integers over here. So maybe that's my way into this question. In other words, trial and error and think about what integers are going to work so that I get 296 times 3. Okay, now 296 is kind of hard to digest, so maybe I'll break that down into its prime factors, make it easier to compare the left and the right hand side. So 296, what's that? 74 times 4. 74 is 37 times 2. Okay, so 296 is 37 times 2 times 4, or in other words, 37 times 2 cubed. So let me get that down here. 296 times 3 is really just 2 cubed times 37 times 3. Okay, so I was mentioning a trial and error approach. What integer values of y and b would yield this product over here, this series of integers? Okay, so should I start my trial and error with y or with b? Well, y could really take on anything, whereas this expression here, 4b plus 1, is only going to take on very limited values, right? 4b plus 1, well, that means it's 1 more than a multiple of 4. Okay, so I have to figure out what numbers on this side are going to be 1 more than a multiple of 4. And if I've done that, I've matched up the right-hand side with the term over here. I'm going to know what 4b plus 1 equals to. I'm going to be able to solve for b. Okay, great. So could 4b plus 1 have any of these 2's in it? And I quickly realized, no, that couldn't be the case, because 4b plus 1 has to be odd, right? 4 times some integer is even, plus 1 is going to be odd. Anything with a 2 in it is even. Okay, so 4b plus 1 can't have any 2's in it. Okay, could 4b plus 1 have a 37 in it? Well, yeah, that's going to work, right? 37 is 1 more than 36, 1 more than a multiple of 4. In other words, if b were 9, it would be equal to 37. Okay, great. So now we're really getting somewhere. 4b plus 1 could have a 37 in it. It could count for that 37. Okay, but what about this 3? Could 4b plus 1 be equal to 37 times 3, right? It could be equal to 37, but maybe it could be equal to 37 times 3, I suppose. Well, let me explore that. What's 37 times 3? I get 90 plus 21, 111. Is 111 1 more than a multiple of 4? No, that's not going to work, because, well, what's the closest multiple of 4 to 111? Well, 100 is a multiple of 4, 104, 108. That's my closest multiple of 4. And notice 111 is 3 more than a multiple of 4. I'm looking for numbers that are 1 more than a multiple of 4. Okay, so I've ruled out all the 2's. I've ruled out 37 times 3. 4b plus 1 has to be equal to 37. It's the only element on the right-hand side that it could be equal to. And if 4b plus 1 is equal to 37, I can solve for b. And I get what? B is equal to 9. Okay, great. So the correct answer for this one is C. All right. So what do you want to take away from that question? Well, first, don't get intimidated by the large amount of language, the deluge of information that you're given, because at the end of the day, these questions are always going to be dealing with the same fundamental algebra, number properties issues, all that kind of stuff. Anything else to note? Well, notice this question kind of took a swerve. It seemed like it was an algebra question for a lot of the way through, but then we hit this brick wall, and that's when the number properties tools come in, right? I can't solve for y and b directly, right? I can't just, find a value of y and plug it in. But what I can do is use my number properties tools. Think about, well, the fact that these are integers really limits their values, do some prime factorization, use some number properties logic, and again, that leads me to the conclusion, 4b plus 1's gotta be 37, so b has to be 9. Correct answer here is C. All right, well, I hope you found the video helpful and maybe even enjoyed some of those challenging questions. Thanks for watching, and I'll see you next time.